me show the slides again? Thank you. We're trying to work with 3 different pieces of technology at once, so. Well, anyway, the goals of the session are, I'm Ann Bostrom. For those, I'm re-recording this, I just realized. I'm Ann Bostrom from the Evans School at the University of Washington and also associated with AI2ES and CSDE. So AI2ES is the National Science Foundation AI Institute
For research on trustworthy AI for weather, climate, and coastal oceanography.
Thank you. It takes teamwork. And CSDE stands for Center for Studies in Demography and Ecology here at the University of Washington. And we're very pleased to be kicking off this first plenary discussion. We have 4 panelists who will start the discussion. And before I dive into that, I was hoping to show the second slide there. If we can get it to show. Yeah, which shows the purposes of, it's too small for me to read. Maybe you guys can see it. Yes, to remind you of what we're trying to achieve with this discussion. So we realize that from looking at what your teams are doing, we think that not all of you are using AI or machine learning yet, and that this is an option that might be useful to you. So we wanted to have this discussion to talk about how AI can be used to overcome many of the challenges that are posed by the integration of all these different kinds of data. For example, environmental data and the demographic data that have mismatched temporal or spatial scales. The panel is going to introduce the state of the art regarding AI methods for data integration and highlight opportunities for methodological advancements. And each panelist is going to have 3 to 5 minutes. This panel is intended to queue up discussions of the kinds of topics that Jason will be covering tomorrow in his tutorial. So we'll have more opportunities to discuss this tomorrow and going through the rest of the workshop. So with that, let me introduce briefly the 4th panelists. First, we have online Dr. Amy McGovern. And Amy is the professor at the School of Computer Science at the University of Oklahoma and the School of Meteorology. And she's also the director of AI2ES, which I won't say the whole name of. Her research—
It's right there on my slide, on the background.
Yay. Her research focuses on developing and applying trustworthy AI and machine learning methods, primarily for severe weather phenomena. So she's perfectly suited. She received her PhD in computer science from the University of Massachusetts Amherst in 2002 and was a senior postdoc there until she joined the University of Oklahoma in 2005. She received her Master's of Science from the University of Massachusetts Amherst in 1998 and her Bachelor's of Science with honors from Carnegie Mellon in 1996. Our second panelist will be DJ, or David John Gagne. He's a machine learning scientist and head of the Machine Integration and Learning for Earth Systems Group, or the MILES group at NSF NCAR in Boulder, Colorado. He's led the development of machine learning systems that enhance understanding and prediction of high impact weather. So again, perfectly suited to this context, and critical Earth system processes. He received his PhD from University of Oklahoma in meteorology in 2016 and completed a fellowship at NCAR, the National Center for Atmospheric Research, before assuming his current role. He's a leader in AI and the AI2ES Institute and a LEAP Science and Technology Center member. He's a WMO, World Meteorological Organization, nowcasting and Mesoscale Research Working Group member, and has done a bunch of other things and has been really phenomenally important in leading the summer school that are the hackathon type things that we've run through AI2ES. So thank you, DJ. Next will be Jorge Solis. Dr. Solis is a postdoc with AI2ES right now, working with Amy, Dr. Amy McGovern. His interests encompass the development of AI models grounded in robust data and physical principles to tackle the kinds of challenges that we're looking at here, among others, but also industry challenges. He earned his PhD from the University of Oklahoma, where his research focused on harnessing machine learning and satellite data for crop monitoring and yield forecasting. He has expertise in geospatial technologies, environmental modeling, and machine learning, and that has contributed to projects at NASA, the Army, and the National Science Foundation, and the USDA. And he works with a private company as well as on AI, ML techniques and data interoperability issues for the development of trustworthy and robust predicting models in the kinds of contexts that we are examining here. So it's very central to the CAT demonstration project And then last but certainly not least, here at the University of Washington, we have Dr. June Yang, who's a research scientist with the Center for Studies in Demography and Ecology and the eScience Institute here. So she's our bridge between eSciences and CSDE. She's a computational demographer and focuses on applying natural language processing methods to the study of population family formation processes, gender disparity, and demographic inference. She is expanding her skill set by using large language models in text data annotation and measurement development. And she has other research focusing on complex survey analysis that focusing specifically on using network-based samples to study vulnerable, hard-to-reach populations, which is a topic of particular interest in this workshop. She's also had experience working with large administrative data sources, which are important in this kind of work. She received her PhD in sociology from the UW with concentrations in demographic methods and social statistics. Before starting her PhD at the UW, she worked as a research analyst at the Development Data Group of the World Bank. Welcome, June. I'm so glad you could be here too. And with that, I'm going to turn it over to Amy. Each panelist will have to speak for a few minutes, and we're open up for your questions. So we hope you'll collect them.
Amy has a question. John happens to be online too. Is John supposed to be part of this panel, or is he just here to listen?
He's here to listen. John is part of the organizing committee. Thank you.
Got it. Just wanted to make sure he wasn't supposed to be introduced because he is here.
John Williams, who didn't get to introduce himself at lunch, so you know, John Williams from the Weather Channel is part of the organizing group as well.
Hopefully he showed up there and waved because he did turn his camera on briefly. So, okay. I just wanted to make sure. Okay. Well, I'm going to be much less than 3 to 5 minutes because I didn't make any slides. I was just trying to think of ways, and I was being very generic. I'm a little bit worried that you wanted much more specific answers to the questions you sent us. So I hope that my answers they're pretty generic. And sorry, in the background, there's a lot of noise in the kitchen. I hope it's not transmitting through my headphones. So the question you sent was what AI models can be used to overcome challenges with data integration, and then what are the benefits and drawbacks? And the first one that I have is generative AI. That I was thinking about this one. This is probably not your expected first answer. My first answer that I was thinking of is you could use generative AI to verify what you're ingesting makes sense with the other data. So if you ingest data of one modality, then you can use that modality to try to generate the data in the other modality and see how they look and do a comparison between them. And that might actually give you some idea that what you're ingesting is actually decent. And that leads me to my second one, which is that I think a more traditional one that could have been used is that there's going to be, if you're doing all this data of different modalities, there's going to be gaps in the data. And I think you could use the AI to do the gap filling. It's often on different temporal or spatial scales. And so if you could use the AI to do the gap filling and do it in a way, I should have said this for the first one too, everything that we talk about is trustworthy because that is in our name. And Anne hasn't had as much experience saying that name really quickly as me. But you know, everything we're trying to do is trustworthy. So when you're trying to do this AI for data filling or AI to generate different data for a different modality, I would want to make sure that what you're doing is not just to quote an interview I just did with somebody on the news, good hallucinations versus bad hallucinations. You want to make sure that you're doing data filling in a way that you believe is actually physically plausible and is a good hallucination. And I said I wasn't going to be 5 minutes. My third way was to use, sorry, the kitchen, it's great. The dinner's getting made, but it is incredibly loud. My office is right here. The third way that I thought of is that you could use XAI once you've trained your model to, again, I'm thinking about the trustworthy aspect, to peer inside it and make sure that everything that's learned is making a tremendous amount of sense. It's making physical sense, and then it's actually generating something, especially if you're doing this data filling, right? If you're trying to fill in data from one modality to another modality and you're saying, I don't know, I've got data that's available every half hour and another data that's available once a day, and I want to generate that data onto an hourly data set, and it's only available at little bits of spots, and I need a whole gridded map. I need to make sure that it's consistent. So you could do your eyeball check and say that it's consistent. There, I went recording. Or you could, you could use XAI to go backwards and also see that what it's generating is actually good. And I think that is the end of my 3 to 5 minutes.
Thank you, Amy. DJ.
Yeah, we want to go to those. Is everyone driving the slides?
Thank you. That's what I was doing.
Yeah.
So, well, Marsha's bringing up the slides. Go to slide 5. Okay, so kind of building on some of the things Amy was talking about in terms of matching things across space and time scales, I want to give the example this is from a project I worked on with a number of people, in particular, Rebecca Morrison and Oya Lahoney, called, this is our crisis, it's a community, I'm not gonna remember the afternoon off the top of my head right now, it's middle of the afternoon, but the idea of this was that we wanted to integrate weather forecasting data and societal data to try to estimate, like, from a forecast perspective, the potential tornado exposures, like how many people in an area are exposed to a potential tornado, given like the weather environment and the time varying population data in a given area. So why this is important? So here's an example from downtown Nashville. So if you pull in data of the daytime population and you draw a tornado track, which is represented by this black rectangle, and if the tornado were to hit in the daytime, like 11,000 people will be exposed to the track. But the same, basically, it happens a few hours later, only 300 people would be exposed to the same tornado track. And so one of the things we're interested in is like, is there ways to predict this level of exposure? But to do this, you need to bring in both the weather data and some kind of time varying population data. So in this case, we were using the Landscan data set, which gives you this day and night, and there's some other data sets we also looked at in the process of examining this. But some of the challenges we ran into are, one, the weather data. So if you go to slide 6.
Was that?
Yeah. So the uncertainty in where a tornado is going to happen is quite large, even hours, like even minutes before a tornado occurs. But there is some predictability in like saying what region of a given area is more likely to produce tornadoes. So if we have the top row, we have the probability of tornado derived from a machine learning model applied to like an ensemble of weather model forecasts. And then we can also derive other properties about those tornadoes, like how long, if a tornado did occur, how long would the track be? So that's the bottom chart, probability of tornado area greater than a certain threshold. So we see they're similar but different. So like you can have the potential for a long tornado in an area where there isn't a tornado. So that's something you have to account for, is we need to be able to go from this broad scale, what's the chance of a storm, to generating synthetic tornado tracks, so that we can get to the scale of the people, which are affected not by the overall storm, but by the individual tornado. And because we don't know exactly where the tornado is going to form, we have to sample a bunch of these tracks and overlay them on the population data. So when we do this, we can get this third map, which is the probability of exposure, conditional on a tornado occurring. And this looks a lot like a population map, because there's some relationship, but there are some variations that are weather related. So figuring out how those intersect is really crucial. There's also validating how well is your model performing at each of these steps. So like one of the ways we do this, because tornadoes are really rare events, is we have an unconditional model that is the probability of tornado, but then all of our other models are conditional on tornadoes occurring. So we're able to basically not have a bunch of null cases where there's no tornado, and that allows us to get a stronger fit to the data. And it's something like, if you can break up your problem such that you don't have a hugely imbalanced data set, and conditioning on relevant factors is one way to do that, then you're more likely to find something that fits well. We also brought in stochastic elements we used a GAN to sample tornado tracks. There's other generative methods one can use to if you have some kind of stochastic element you need to capture. And then generative adversarial network. So final part of this, I think, is like, you really need to have people who know basically like at least experts in one part of your data stream. So if you like often the team analyses of this will lean toward whichever side of it the expertise lies, and then that underweights the complexities that have come from the data sets you don't know about. So ideally, you want to work together with a multidisciplinary team to be able to understand all these different pieces of field, to explain them, understand the subtleties and how that data is being put together. So hopefully, I'm hoping this workshop is a good opportunity for us to bring like kind of these different expertise and all these different data sources together, and hopefully learn something from each other in this process and make things where we account for all these uncertainties together.
Thank you, DJ. Over to Jorge.
Okay, so, well, good afternoon, everyone. So when we're thinking about the challenges of data integration, it's hard not to think about data interoperability. So we are getting more sources of information, we have more data, and yet it's more challenging to take advantage of that information to look at a specific phenomenon. So, for example, with social hydrology and severe weather forecasting, we can get multiple sources of data. We can have satellites, crowdsourcing, and survey data. And yet, despite having more information about a specific phenomenon, there are some inherent challenges for integrating this data or using it together to answer that question that we're trying to address. So when I think about challenges of data integration, I can think about 5 important challenges. The first one, the heterogeneity of data sources. So if we're working with structured weather data, for example, compared to unstructured social data from social media, that opens the door for challenges. How are we gonna integrate this data and how are we gonna use it together? Now, the spatial temporal resolution, I think that's an issue that we all have faced. Even if we're working with daily weather data, weekly satellite data, and then survey data. So this is a major challenge that needs to be successfully addressed to prevent the uncertainty and also prevent the data gaps. So I think it's important to think that every single source of information that we use, even if it is in the same field, sometimes the purpose of collecting that data is different, and that might introduce some uncertainty into our models. So I think this is another one of the challenges that we face. Now we have dynamic feedback loops that, even though they are not as common, if we want to get closer to a real life application, to an operational deployment, there are cases, for example, if we're looking into urban hydrology, let's look in flooding, for example, or water use. We have the user's water use having a demand in our system, and therefore that's feedback that needs to be input into the model. So how we do that? And finally, the data privacy and ownership rights. So nowadays, even with the mobility data that we're integrating in the CAD project, every single one of us has a device, a cell phone. We can get so much information about each single device that translates as a unique individual. So how can we protect the privacy of the people using this? So next slide. So the next table illustrates some approaches that can be used to help us address some of these challenges. So for example, neural networks, so convolutional neural networks or recurrent neural networks, they can learn patterns from diverse data sets, and they help us to reduce the need for manual feature extraction. In the case of autoencoders, so the higher resolution we have, for example, the largest our data is. This helps us to compress the size of the files and makes ultimately easier to do the data integration. Now, the graph neural networks, they are important because they can help us to capture relationships between different data types. And this way we can link weather patterns with population movements, for example. Now, if we think about this spatiotemporal graph neural networks, this can help us to capture both spatial and temporal relationships. It can help us to integrate, for example, daily weather data or hourly weather data with a monthly social survey data. There are other cases like data fusion. So Bayesian and I'm sorry if I'm not pronouncing this correctly, and Kolmogorov filters, they are commonly used for data assimilation, but they can also help us to reduce the inconsistencies that we can have when we have disparities in spatial and temporal resolutions. In the case of uncertainty and data gaps, I think a common approach that is helpful to address this challenge is the data augmentation. So for data augmentation, we have the generative adversarial network that can help us to generate synthetic data to fill in missing information. So for example, I'm sorry, I'm not going to much though. Bayesian neural networks, for example, that help us to incorporate uncertainty, but this one has a more probabilistic approach. And finally, when we look into dynamic feedback loops, for example, reinforcement learning can help us adapt the decision based on real-time feedback. But for example, data simulation techniques could be useful as well. I think that these methods can be helpful for us to tackle some of these challenges and make sure that we have a scalable approaches to be able to get the insights that we need to get with the more sources of information to reduce uncertainty. Because ultimately, if we're using a AI model, for example, the more diverse our sources of information are, we can reduce the risk for over parameterization, for example. And I think this is important. And with this, I will let Jane talk.
Thank you, Jorge. Building on top of the wonderful remarks given by the previous three panelists, I am more thinking of the challenges in data integration with the use of generative LLMs. If we are, for example, faced with a combination of qualitative and quantitative data, how do we possibly use generative LLMs to help us bridge that gap? And then one of the applications myself have been using LLM is to build measurements of qualitative data by doing text annotation. For example, if we have a bunch of social media data, we also have policy report, and then we also have, environmental and social space data. How do we sort of build measurements of our text data to label the data set so that to combine that data together with our quantitative data set? And I found GPT-4 and possibly other LLM models of great use in this. And that measurement can be aligned with the quantitative data set that we have. And another use case I have is with a very similarly trivial but non-trivial, actually non-trivial step is to use LLM for data pre-processing and cleaning. For example, if we are faced with data sets with different temporal scale, and then we're possibly trying to clean that data set with different names of spelling and also geographies, and LLM can be greatly used to identify the mismatches and help us streamline the process of cleaning that. And then I've also been thinking in terms of how do we present in the report the results we get from integrating data sources from different fields. And I think generative LLM can help us bridge the gap of semantic gaps, for example, in different terminologies in environmental science and social science, and how do we collectively translate different terminologies into the result that we want to present. And LLMs can be of a great use in terms of presenting and reporting. So that was all from my experience. Thank you all.
Thank you. Let's all take this. We'd like to open it up for questions. So while you're thinking about your first questions, that didn't take long. Please.
I'm Kip McManus from Caesar at Columbia University. I'm just wondering if anyone on the panel differentiates GeoAI from AI, or if we think of it all as one thing.
Did Amy hear that?
I heard him. I was going to ask him to explain what he means by GeoAI.
Yeah, I think that's part of the question actually, is what is GeoAI? And I think the maintenance of hierarchical spatial relationships must be part of it.
I mean, I would rate the AI2ES is focused a lot on AI for weather and climate applications, right? And that means we're doing GeoAI by your definition, but we just talk about AI. I don't talk about it as GeoAI. So.
Yeah, I think a lot of what you see in AI, and maybe I'm wrong here, please tell me I'm wrong. It's really what in GIS we would call a focal statistic, where it's some local neighborhood, maybe at multiple scales, but the scales don't necessarily know about each other, and they don't really know what's beyond the edge of the local neighborhood.
I think that's actually not true anymore. And there's a paper that just came out from ECMWF that would dispute that. There's a nice regional modeling paper that matches their blog post they put out recently about doing multi-scale modeling for the AI-based, their AIFS model that's doing it for over Norway. I can put the link in the chat and somebody there can share the link back out. I can put it in Slack.
Thank you.
Yes.
Yeah, I wanted to have a quick addition to it. I mean, yeah, I think there's a lot of geographic specific contextual knowledge that can separate geo or weather or climate AI from from the broader scope of the AI world. That said, there are also a lot of cross-cutting problems that we can use other AI architectures that may be like originated in other subfields or other applications that we can then bring over to our case. So like one great example of this is UNets, which were originally developed for like medical imagery and segmenting like pieces of medical imagery, but then they turn like the things that make them successful for that also make them successful for just about any other spatial multi-scale problem, and they're fairly easy to use, so they're like now like omnipresent in all kinds of places. So I think that probably the bigger takeaway is identifying like for given from what extra contextual knowledge we need to use that is not in the general purpose algorithm. And I mean, this is true for all statistical stuff as well. That's why there's a whole geostatistics that's not, or spatial statistics that's not kind of its own subfield in statistics, is because there are certain needs that like more generic assumptions just have.
Thank you.
Jane, yes.
So I think multiple panelists mentioned using generative AI to fill in missing gaps in data. And Jorge, you had a slide up that said that, that can help, from the, performance of the models being reduced. But if there's missing data, we want the performance to be worse, in that there should be larger uncertainties in the predictions. And by in-painting, aren't you just being overconfident about your predictions, because you're basically using other data to just guess what it's gonna be, and then using that as the ground truth to then make predictions. So I'm wondering if you're concerned about sort of, feeding in what you already know, in terms of overconfidence of your predictions.
I think you have a legit concern with that, and one of the things my group has been working on for the past, like year and a half, is looking at more misleading methods, that AI methods that can incorporate, not just predict the uncertainty, but also not just predict the prediction, but also predict both aleatoric, which is a kind of uncertainty from the data, as well as epistemic uncertainty, which is uncertainty from your assumptions about your model. So one use case for this is like kind of that in-painting element, where you want the uncertainty to be kind of low. It's very similar to existing example, but you want the uncertainty to increase as you get further away from that, and then somehow propagate that uncertainty into other downstream pieces of your system. And kind of in the weather prediction community, there's already some ability to do this through things like the data assimilation. There's ensemble data assimilation methods that you'll get wider spreading results if when you're trying to fill in information where you're further away from observations, and less spread when you're when you have an observation. So to some extent the weather field accounts for that, but AI approach definitely don't. And I think you bring up a legit reason that we need to think more about this. You also see it in LLMs too, where they will sometimes will either make stuff up, or they'll start they're often overconfident in their statements, and this has been a noticeable thing, not just for our applications, but in general.
Jane, do you want to add to that?
So I think especially on the use of LLMs, validation is essentially very important by prompt engineering, and then iteratively adjusting the prompts and then test out with human judgments. That's just absolutely to respond to.
So to follow up on your point about the different methods, I mean, in principle, you want to marginalize over the probability distribution of the missing data, given the existing data, right?
Mm-hmm.
So it is, there is a probabilistic way of propagating the uncertainties. Is that what you're referring to in terms of these different methods that do this?
Yeah, I mean, in the case of the AI, like a neural network, it's maybe doing it a little bit different. There's say, might be running into a terminology difference in it's what, the neural network trying to learn the joint probability distribution of a bunch of variables and represent the most likely outcome, and then maybe some uncertainty around that if you're optimizing to do that. But then to do that properly, you have to have the right optimization procedure that can account for learning the whole distribution and not just the most likely outcome. And that's something I think is still an underappreciated area in the space of AI neural network research. and often you can get some information, like if you, depending on what, also depends on what part of the space you're in. If you're in a part of the space that has like no data representation at all, then you're entirely relying on how the neural network extrapolates. But there, like, one problem I have, I've seen, there's a part of the space where you're in distribution for one of the marginals, but not the other. Or actually, you're still in distribution for both marginals, but then joint distribution is meant like, there's a whole there, so the neural network still gives you an answer. But at least thankfully, the uncertainty actually did increase in that part, so the model was seem to be learning the right things for the right reasons.
Probably you should never be using it out of distribution.
Well, depends on what you mean by out of distribution. So again, it's when you're in high dimensional spaces, that gets, like, there's some argument that everywhere is out of like everywhere is extrapolation. So it's, and when you have data that like is non-stationary, is varying over time, then sometimes you may be, like, where you're out of distribution gets to be, it's not as cut and dry as one might expect from like a more univariate problem or bivariate problem.
Yes.
I think just a reflection on that too, is that, you know, like bad classical models can have the same issue of kind of predicting outside of actually observed distribution. So the whole discussion in econometrics on local average distribution effects and predicting according to mean distributions of variables that are never jointly observed in a population. So, I mean, I think some of these issues that are very present in AI type research are also present in classical research, just kind of understand them better now. There's like better rules of practice around that, which might be still emerging. Yeah.
That's exactly what I was going to say. You mentioned that, you know, at the end of your answer, you mentioned that there's a point in which, you know, the user has to intervene, like when running all these complex models. I guess, like, for the panel, do you have any recommendations on at what point do you sit down and try and validate, and what strategies do you have you employed to try and like sort of validate what you get out of these models?
One use case for my research is that when we try to build a measurement out of their text, I would first try to, you know, take out a small sample of your larger text data and then have your, for example, have your LM label that and generate measurement. And it's always good to have human coders look back at the measurements to see if that makes sense, and ideally multiple human coders. So to compare the annotation come up by the LM with human annotation and to validate how good that is. And also I would pay special attention to those mismatches where, you know, human annotator would assign different value from an LM to see, you know, what are the possible reasons of that, and is there a pattern of the failed cases of LM. And then the process is that I would recommend is that we always go back to the prompt and adjust the prompt that we give to LMs to make sure that we understand the different sort of outcomes we run with different prompts. And then better with few shots learning, for example, you would provide the model with some of the examples that you want the models to follow. And in that case, that sort of generally would improve on how the annotation works. But there's a caveat that with different models you use, for example, GPT-4 or GPT-4o, it's the difficulty is that you're not gonna get very like exactly replicable results every time you run it. So there's a bit of the randomness built into how the GPT models run. I think that's just one of the caveats to be mindful of.
Thank you.
Are there any other panelists want to comment?
I think if no one else wants to go, the three of us, with one of y'all. And I think a couple of key things in the evaluation I found to be kind of crucial. One is like plotting, like making visualizations of like every step of your data process as you go along. I've run into a number of projects where you get all the way to the build your ML model and start evaluating, and then it turns out there's a data problem like 3 steps back that kind of invalidated everything after that or caused some weird artifact. some other underappreciated things I think we should probably adopt more of. Especially with more subjective evaluations, there's always a risk of, like confirmation bias essentially, like I do a lot of work with explainable AI and it can give you a number and, or ranking of variables or a heat map or something and often it's easy to post hoc justify, like, when you see something like, oh yeah, that makes sense. But it could have given you something else that you could also make the same argument either way. So ideally, you have some kind of free, like either blinding or other way of like providing a hypothesis. I think it should, like, I would expect it to do this based off of what I know or based off of some other field or have something that prevents you from being able to basically justify it after the fact. It's still a very manual process to do that. I don't think we completely solved that whole issue. Also, I think running, if you have the opportunity to run these algorithms in like a real-time setting where where you can't know the answer beforehand, that's also a particularly effective way to validate this stuff because like, even with held out test sets, there's still like, there's always the temptation or the practice of like, once you look at it once, the value of its scoring basically decreases because information indirectly is being used to change further iterations of the model. So it's something we have to watch out for in our evaluations.
Yeah, so what might, for June, I guess, what might you say to someone who's skeptical that you can do science with ChatGPT, given, you know, it's a commercial product, it's constantly evolving. You can do prompt engineering, which you alluded to, but you have no control over the seed, which you acknowledged, you know, means that the results are not reproducible. I mean, is this a concern that's out there? What are your thoughts on that?
I think that the current best practices scholars have been recommending is to use open source models instead of GPT-o, especially if you have data security concerns. It will be recommended that scholars use open source models that feels transparent and reproducible, and then host it on their own university servers. I think that's the current practice, but the caveat is that which one performs better. I think sometimes, at least in my own research, at the time when I was developing my research, GPT-4 sort of performed the best, but I'm pretty confident, other models, open source models will catch up.
Comments, questions?
This is more, I guess, just a curiosity. But based on what everyone has said, and since we were talking about forms of uncertainty earlier, it sounds like we can use these tools to try to address problems around aleatory uncertainty, but for parameter uncertainty and epistemic uncertainty, they're kind of maybe not particularly useful or reliable, and even how useful they are for aleatory uncertainty depends on how well constrained those other forms of uncertainty are for us. So is that, I'm just more curious, is that fair to say? I don't want to pass that on to students or something. That's wrong, but.
I'd say so like if you just use an off-the-shelf neural network, aleatory uncertainty is covered pretty well. Epistemic, like if it's just a single model, it's not. If you have a model that predicts an ensemble of models that predict a PDF, you can get some degree of, you can estimate your epistemic uncertainty. The tricky thing with epistemic is that it's inherently a kind of a Bayesian concept because you have to define what you consider your hypothesis space, which can be not infinite, depending on how you're defining it. So if you have some idea, like basically way to make that a more finite definition, then you can quantify, I think, something that looks like an epistemic uncertainty. There's definitely work on parameter estimation with neural networks or with machine learning methods, and you can, either with things where you could like map propagate and have it as like another weight that you're just like kind of tuning, or if you have some kind of more forward-based, like there's been some work at NCAR doing emulator models to like kind of get a parameter estimation where they emulate like some kind of more complex physical system, and you generate a whole bunch of samples, and then you can look at what the distribution of the parameters are for the models that fit that distribution well. But it's doable, it's still, I think, more in its infancy, it's not the, like, off the shelf ML, but there's certainly ways to do it, and, you know, the epistemic, yeah, there's definitely also ways to do it. Like the evidential models that I've been playing around with seem promising, although there's a calibration issue of like defining your relationship between your aleatory and epistemic that come up. So, but it's definitely an open area of research that I don't think we have the settled answer on all these methods have their trade-offs.
What are some of the best examples you've seen of these approaches solving problems in this specific application area for any of the panelists?
Can you be more specific with specific application area?
Environment and population, let's say. Like, are there any great examples where you say, oh, that really solved this problem that people have been struggling with? Or is it still kind of something we could do in a few years?
Yeah, I would say there, yeah.
I only half heard that. If it was for me, I only half heard it.
Yeah, could you speak, say it again?
Yeah, are there any particularly good examples where you've seen these approaches solve big problems in the field of population and environment?
Did you hear that, Amy?
I did hear that. But if we're talking about population data, I'm gonna still let DJ answer whatever he was about to start answering.
Yeah, I would say, like after doing at least the the project we worked on, feel like there's still a lot more to be done. We've only scratched the surface, just because there's just a lot of decisions one has to make and uncertainties one has to account for. I don't, yeah, so I wouldn't say it's necessarily solve the issues, it's maybe like one thing it can be helpful, like bringing the AI component in this process. I think can be helpful is trying to summarize or represent much more complex data, so being able to like ingest in like whole like tornado soundings and lots of weather data. I don't think you could do that with traditional. I mean, you could potentially do that with some traditional spatial statistics, but you wouldn't be able to cover you have to have a much more handcrafted pipeline in order to do something. But it's still, yeah, there's still a lot of sensitivities. It's still, yeah, I know I've seen people work with like traffic data and like AI traffic modeling kind of stuff using like graph neural networks. That there's been some interesting papers on kind of in that space. Like I can't say I can point to, oh yeah, this is the one that solved all these issues. I think everyone's just like, this is an early problem. This can help in certain ways, but also has other challenges due to the nature of how the uncertainties and geographic stuff and everything interact.
Jorge, have you run across any good examples?
Yeah, well, there is a good example. I cannot disclose the specific architecture utilized in the framework, but basically it's in the area of agriculture. So you have the modeling framework where you have the field conditions and what's going on. So one of the biggest challenges is how accurate is our model. So you are able to integrate the data from the fields. So the farmers take a photo and that photo goes right into your model. The AI framework helps you to evaluate that data point, and based on those results, it's gonna retrain itself and try to have a more accurate results using that direct feedback that you have from the field. So that is one of the applications that I think is really exciting because you are able to retrain the model with the real data and getting more accurate results. So that is one of the applications that I have seen that are the most exciting. And I don't know, June, I wanna add something?
One of the examples I could particularly think of is the studying the sentiment and semantics on social media of, internet users around climate change, around extreme heat, for example. Question would arise, what are people talking about? What are they expressing when they encounter disaster, when they encounter extreme weather? And then I do think text data LLMs can be of use to build measurements out of those sentiments and then, combined with what is actually happening in that area to see what are people's responses to the events.
So my takeaway, Amy, did you have anything you wanted to add?
I was just thinking that when we finally have data, it's been a long journey trying to acquire mobile data, but that, we might have some success stories to be able to tell as well out of this, right? About how people are responding to major events.
Yeah, so that was my thought too. This is a great question. And so hopefully we can end up with a library of good examples resulting from this workshop and the projects that you were all engaged in. And be useful for the field.
Yeah, exactly. That would be a great answer.
So I'm not by any means an expert in AI, but I do want to, or machine learning, but what the most useful thing I think I've seen, and so I'd be interested in hearing you all comment on this, is the use of random forest to identify patterns and data that we might, it's basically data mining, right? To figure out how we can identify patterns that we didn't theorize would be there. And it often involves combining data that aren't typically collected at the same, together, because we might find something unexpected in combining different types of data about population and environment. So I'm curious if you all, what your sort of the best practices would be to that sort of random forest approach to discovery.
Amy, do you want to take the first crack?
I'm getting 75% of the questions, so it's hard to be answering what the best approach to using random forest to doing data discovery. Is that the summary?
Yeah.
Yes.
Yeah, no, I'm thinking. I think that's the answer. I'm thinking because it feels like there's a lot you could do with random forest, but if you're just doing a random discovery through your data, a random walk through your data, I'm not sure you're going to get what you're looking for, right? I assume you're doing random forest to do a specific task through your data to understand your data better. Are you choosing random forest because they're more interpretable? Is that what you're choosing them for? I guess I'm trying to understand the task better.
So I'm not actually doing this. I'm just saying that, when I've looked at the different tools that you can use with AI, this seems to me from a social science perspective to be a way of discovering something in, let's say, administrative data that you didn't collect with an intentional purpose in mind. And so there might be patterns in an administrative data set that you wouldn't have expected. Is there a kind of approach to looking through administrative data to try to discover patterns?
I mean, when I talk about pattern discovery through data that you don't actually know what the data contains, a lot of what we talk about is more unsupervised methods than something like a random forest. So more clustering or data visualization techniques, because it gives you a chance to go explore what parts of the data are similar and what parts of the data are far apart. And that's more what I would think of than a random forest.
I mean, I think with the random forest, the advantage you have for like if this, assuming when you say administrative data, this is like some kind of tabular data set with like a bazillion columns or something like that.
But you know what's in the columns, and you have an idea of what's in the column. So yes, it's tabular data. I mean, you can think of like an administrative record data set may include like medical records, health records. And so you would have patients and their diagnoses, and you're trying to figure out like, gee, what kind of diseases cluster together? That sort of thing. That would be.
I would imagine you're also looking for patterns that like maybe you didn't think of. You said something about that. I wouldn't use random forest to do the random walk through my data. I would use clustering or something like that. But the random forest, if you were doing it to, I don't know, predict what kind of, what disease, a specific thing, what you might get out of that is you might find those patterns that you didn't expect. That you said something about data that you didn't expect that you were collecting, right? Or maybe you thought you hid all the racial data, but now you find something that shows a racial bias or something like that. I feel like the random forest would be really good at that, if that's where you were going.
Yeah, Is it, the benefit of random forest is that, like, they don't make a ton of, they make very little assumptions about the data properties. And they do some degree of, like, kind of feature selection via the tree construction that allows you to, like, if you have lots of, like, basically a high, like, many rows and many columns in your data set, they can help sort the more relevant ones, and then between all the trees, you can see which features consistently show up across the trees to maybe flag them as something that is relevant for the problem, if you're going back and then doing some kind of feature importance ranking or partial dependence plot or whatever. The dangers of random forest in the discovery cases, they are effectively a nearest neighbor kind of model, so they, like, because they don't make a lot of assumptions, there can be some, that can, like if you use it out, like, good for interpolating in the space of the data, but you're assuming there's just continuous stuff in the data, that's great. If there's some kind of continuous smoothness that you expect in the data, random forests and tree based models are not usually great for that, that kind of data. That's where, like, a neural network or a regression-based approach probably makes more sense. But I would also bring up if you have no idea what's going on in your data, how it might relate, you probably want to start with something that is a simpler model so that you can at least understand some of the base relationships, or make some hypotheses by, I think these variables should be important, and then check if they are once you fit your model. So you can avoid that have some hypotheses going in, so you can confirm or disconfirm those hypotheses, rather than, like, just see what the data reveal. There's another interesting method called explainable boosting machines that's come out of Rich Caruana, Microsoft, so, like, from around here. That basically what he has, like, a version that uses kind of boosted decision trees, but also one that uses, like, splines, I believe. And the idea with that is you fit a kind of nonlinear model on each variable individually, and then you have something that kind of combines those nonlinear fits at the end. And the advantage of this is if your data set is relatively, like, not terribly multidimensional complex, like for tabular data, this can work well, because you can then see the exact relationships between all, like, the variations in your input and what the prediction is, and in cases like medical data, that can allow you to catch like, artifacts in the data, which could include, like, bad data, but also there's sometimes leakages in how, like the example of, I think he has an example of, like, pneumonia. There's, like, patients who are, like, sicker, the model predicts, like, I have better outcomes, and it's because at a certain threshold, they get more intense treatment, and below a certain threshold, they don't get the intense treatment until later. And so it predicts, like, being sicker gives you a better outcome, which is non-intuitive, but it's just is an artifact of the medical diagnosis system and how they triage patients, essentially. So being able to kind of have models that can pick up on that kind of stuff, and then be adjusted to have it, like, either remove that or account for that somehow. It is really, I think, maybe crucial for getting over that hump toward actually using these in practice.
Oh, boy.
Yeah.
Let's see.
All right, thanks. Yeah, so the Institute's name uses AI, not ML. So I think, like, pretty much everyone here would agree, like, these are really useful ML techniques. And as I'm trying to piece together, like, what's the value add from the AI piece of it? I think what I've heard that I've kind of latched onto is that it kind of makes the pipeline faster and easier to access and use these tools. You don't have to, like I said, hand build the work, but do you have a different idea of, like, what's the value of the AI separate from the ML? Why do you use the word artificial intelligence?
I can give an answer to that. The name of our institute was chosen by NSF, and we had so. First of all, they said they were AI institutes, so we named ourselves as that's where the AI2ES came from. We actually had an acronym. When we got our funding, NSF said, "This is your name," and we said, "Yes, sir," because we don't turn down funding for $20 million. We actually tried really hard to say, "But can we keep our acronym?" And he said, "You can keep your acronym. You're getting this name." So that's probably not the answer you were looking for, but the AI in it is because NSF called all of the AI institutes, whether it's AI or ML or the broader scope. And all of them start with NSF AI Institute. It's branding.
I'll say for my group name, Miles, yes, I intentionally picked it's in machine integration and learning, not AI. And that, because I think a lot of what we do is at the level of ML, and AI is such it's one of those terms that like when the money is coming in and there's a lot of, like, everyone wants to call it AI because that's the thing, but since I started as like a student with Amy back in the day, AI was kind of the word to avoid using when and we went through various cycles of coming up with their like informatics and analytics. I mean, those are their own things in some ways too, but there's certainly some level of buzzword and terminology kind of marketing that goes into this. That said, AI doesn't incorporate any other non-machine learning methods like expert system type things and logic-based sort of things. Some of which, I mean, have kind of fallen out of favor, but some of which are still kind of embedded in how we like do these systems. Usually the ML part is like one piece of a like much more complex thing that has lots of like hand done rules and stuff that would to make the whole AI system possible.
Sorry, we had two other hands up first, and then we'll go back to.
Yeah, maybe, and someone that's not in the machine learning, AI and working environment of more background with statistical econometrics tools. I mean, there was reference earlier, and also in your title, Amy, this about trustworthy AI and what it really is, because I mean, you had this discussion earlier about the fact that some AI model doesn't necessarily reproducible. Then you suggested so you should try to trust what's open source, kind of sort of set of principle, right? How it's being published, how it's being transparent. But then you also said, well, I prefer to use ChatGPT because it's actually perform better. So what is trustworthy AI? How should we access it? So I think that's just not my question.
Amy, do you want to answer this? Could you hear it? He wants to know what trustworthy AI is.
And you should answer that.
We just went through an exercise, describing this for some reviewers last week. But,
I'm still traumatized from last week.
do you not want to take a try? No, you don't.
I mean, I feel like Anne and Julie should answer this because we got this exact question in the review. What is trustworthy AI? And can you just design a metric in order to do this so that people could just have a checklist and go through and say, this is trustworthy and this is not trustworthy. So I'll give a pass since I'm on the panel, but Anne and Julie are better to come back in because I can see Julie. The camera, the owl is showing me Julie in the audience, so I know she's there.
You're there in the room. You see Anne.
Yeah. But okay, the definition of trustworthy is in the eye of the person who is doing the use of the AI. It is not a single definition that we can give you that there's a checklist that says this makes it trustworthy AI. And part of that definition is very context dependent. It's what context you're using the AI in. So if I'm going to give you a weather example, if I train my model in Oklahoma and then I tell you that my tornado predictor works really, really well, but you take it to Wyoming, you want to see if it works in Wyoming because the weather in Wyoming is actually different than the weather in Oklahoma. And then I would also say that it depends on that use, so that long-term relationship with it over time. And it depends on some base level of performance, right? I mean, all weather models are bad, but some of them are useful, but you'd like it not just to be terrible all the time. There's definitely some level of baseline of performance. I got context dependent. Some people want to see inside it. And I think that a frustration, Anne and Julie probably agree with me on this, a frustration is the number of people who make a statement in a paper that if you create an XAI model, it will generally give you a trustworthy answer. That you'll automatically understand the AI, but that isn't the case. Not everybody wants to see inside their model. Some people just want to see how well it works on case studies, and some people really want to try to jump inside the model and really understand it. I probably missed more. Anne and Julie want to jump in?
Oh, Julie?
I was gonna say, actually, Anne, I think it's a good idea to start, and I just pulled it back up too, with our definitions.
Sure.
Because they do recognize that there's no single answer. Do you want me to read this?
Yes, please.
Okay, so we do have on our aa2es.org, we have a glossary. And that our definition of trustworthiness that the definitions team came up with, which pretty much jives also with how we tend to think about it in the whole aa2es and the research we do, is that trustworthiness is a trustee's, the person who's doing the trusting, their evaluation or perception of whether, when, why, or to what degree someone or something should or should not be trusted. So this takes me back. The other thing I'm gonna do here is then give you the definition of trust. If my computer loads the definition of trust. And I think this is actually what's really important too, is that trust, as we've defined it, is the willingness to assume a risk by relying on or believing in the actions of another party or a model or another entity. You want to build on that, Anne?
I think that sort of says it all.
Because I think what we did with those definitions, that's how we conceptually define these concepts or constructs, drawing on a lot of literature that comes from a lot of different domains, whether it's the social sciences, AI, et cetera. But I think what Anne and Amy were already discussing though is then how that gets operationalized for an individual utilizing certain AI for certain purposes, whatever those decision contexts are, is going to vary for a lot of reasons. It doesn't mean that we don't see commonalities in the kinds of things that matter to shape their perceived trustworthiness. One of the things you'll note is that in aa2es, what we often do is call it perceived trustworthiness, to sort of reflect sort of the perceptual or subjective nature of it and the context dependence of it.
So in some recent papers that we published, one of the things that we pointed out is the context dependency that Amy talked about, and especially with weather forecasters, for example, they want to know how the model is going to behave in the context that they're in and the specific weather regime they are working in, and to see that it's actually going to be functional when they need it. For weather forecasters, the model also has to run fast enough and be accessible enough for them to be able to use it operationally. Otherwise, they won't be able to trust it in the kind of incidents that they are trying to work in and the decisions that they're trying to support. But the performance the last thing I just want to add is that performance is often, we're in the middle of a systematic review right now, and these things hold up in the papers we've looked at so far, that performance is often very important. The performance gets measured differently by people with varying types and levels of expertise. So when the global first data-driven global models came out, like Pangu Weather, they were just measuring root mean squared error, RMSE. But that's not I mean, there are lots of other different metrics, very specific metrics that weather and meteorologists and weather forecasters use to look at the performance of a model. And RMSE may not be the best measure at all of performance to use in that kind of a context. This goes in spades across medical use contexts and other contexts. They have other ways of thinking about skill and performance of a model. And you can think of even like using a specific tech, you guys are gonna correct me if I'm wrong.
Yeah. No worries.
Okay, so you can think of this might go for even the use of different modeling techniques that they may be more or less useful in different domains for some purposes, depending on the kinds of performance that are necessary for that domain, for that application, which is why the decision context that we've tried to highlight for D4 is so important. The decisions that people are trying to make with these integrated models vary depending on their circumstances and their contexts. And NOAA is faced with trying to think about not only sort of how do we serve the greatest good for all the people of the United States, for example, but also how do we protect vulnerable populations that may be a different set of metrics.
Can I add one more little thing? Sorry, then I'll add it to detail. I just said I wasn't on the panel, but the other thing I think that's sort of embedded in when we talk about the definition of trust as the sort of willingness to assume a risk, I think connects to what Anne and Sarah talked about in terms of the role of uncertainty, because risk by definition includes some measure of uncertainty. If you know exactly what a model is going to do or how people are going to behave, then you don't assume any risk. There's no need to have to trust them to do it because it's a given. So I think the uncertainty piece comes in here too.
It's really important piece, yeah.
Yeah, and to add on to, I guess, the perceptual trust or the perceived trust, there's only so many things one can keep in their head at a given time when evaluating these models. And when you're dealing with things like explainable AI, for instance, it gives you some insight as to the innards of the model. In a lot of ways, it's a compressed representation that's usually done via like kind of still treating the model as a black box, but wiggling things around on the outside and seeing what happens. And as a result, you can, some of our methods and metrics to evaluate trustworthiness themselves can be potentially deceptive, which kind of, compounds the difficulty in measuring these things. So I think one way around this is by taking advantage of the fact that trust is perceptual and contextual, and having different kinds of evaluations at different stages of the process, so that we have some level of clearing the goals. I mean, this is what we're already are doing in our experience with a lot of these, the kind of AI development and integration processes. Can they complete the simple task? And then if they can, then our domain experts expect it to do harder things. And so then we can look for those, and we still fall back on the basic stuff in case that, as a kind of regression test, or in this regression in the sense that, did we change something and it broke basic functionality kind of regression. That's where I think with the limitations and advantages of human recognition can come into play when building trustworthiness evaluation process.
Yeah, and just a word for co-production and engagement of users throughout these kinds of processes for that very reason, which has been really important. So we have actually run out of time. I didn't believe it, but is Sarah, are you here? Looks like she stepped out. Okay, Sarah was supposed to introduce speed dating because this was her idea. But I guess she's not here. Okay, so speed dating, Masha, you're gonna jump in and help me. So we felt that one of the main purposes of this workshop is for you all to get to know each other and to find out about the different kinds of work that are going on at this nexus, sort of where we are with trying to integrate these data across environmental and social and demographic contexts. So this is an opportunity for us to have a structured way for your teams to meet each other. And you'll see in your agenda that we've got this divided up into three, essentially half-hour periods, but with a 5-minute transition time, since they're in different spaces. And they're numbered by space. So the first, number 1 is this room. Number 2 is the eScience seminar room. Number 3 is eScience common area. Number 4 is the eScience meeting room. And you can also go outside, the sun has come out. So, but if you go outside, please come back to the next session so you can find your partner team. And so for the first period, we're gonna do 3:50 to 4:15 Demas. We'll be meeting with the Columbia Hurricane Migration. FSU and Penn State will be meeting with Flame to Flame. The Flusters will be meeting with the disaster demography.